Thanks to Jacob Friedberg for my awesome intro video. This is your video for 10.4. This is surface area of cylinders and prisms. So I know you studied surface area in middle school, so hopefully this will be a refresher. So prisms and cylinders have two congruent parallel bases. A lateral face is not a base. So it's lateral means side. Like in football, if you throw a lateral pass, you're throwing it to the side, not downfield. So lateral means side, and it's not a base. The edges of the bases are called base edges. A lateral edge is an edge on the side, not on the base. And the lateral faces of a right prism will be rectangles. So we already learned that faces of prisms were parallelograms, but when it's a right prism, more specifically than a parallelogram, it's actually a rectangle. An oblique prism has at least one non-rectangular lateral face. So basically a right prism is going to sit straight up and down. There's going to be right angles where the base meets the lateral face. An oblique prism is basically going to be tilted to the side. So here you see all of your vocabulary that we just put in that paragraph right there. Okay. An altitude of a prism or a cylinder is the perpendicular segment joining the planes. So we know altitude and height are synonymous, so that is still the case here. And we know when we're looking for altitude and height, we're looking for that perpendicular segment. So this picture is of an oblique figure, so one that's tilted. So the altitude will actually be outside the figure, not the actual lateral face. But if it's a right prism, then the lateral edge is the height. So that'll be easy, and those will be the ones we work with most often. Surface area is the total area of all the faces and the curved surfaces of any 3D figure. The lateral area, again, we know lateral means side. So the lateral area is just the area around the sides. It doesn't include the bases. So you have to be very careful when they ask you to find the surface area. If they just say surface area, they mean everything, bases included. If they say lateral area, they mean just the sides, don't include the bases. The net of a right prism can be drawn so that the lateral faces form a rectangle with the same height as the prism. So we saw this with cylinder, and we saw this with all of our prisms when we did nets a couple of days ago. So here I have a triangular prism, and I can draw the net to where I have rectangles around the middle and my two bases on each side. And what you'll notice is that the length of this rectangle is the perimeter of the base, A plus B plus C. The height of the rectangle is the height of the prism, and that will be the case all the time. That's why you're going to notice perimeter in all of our equations today, is because perimeter is the same as this rectangle, what we're going to find down here. Okay, so this is tiny. I'm going to zoom in for a second. Alright, so the lateral area of a right prism is pH. So remember, capital P stands for perimeter of the base, and then height stands for the height of the prism. Then total surface area, you're going to have your lateral, and then you're going to put your bases on. So pH for lateral plus 2 big B. Remember, big B stands for area of the bases. Then you actually get a shortcut for cubes. Cube is 6s squared. 6 because there are 6 faces on a cube, and then s squared because side times side is how you find the area of a cube. So 6s squared gets to be our shortcut guy there. Alright. A surface area of a rectangular prism, you kind of get a shortcut. Instead of using pH, it's kind of confusing with a rectangular prism because anybody can be the base of a rectangular prism. They're all rectangles. So one way to do it is to say that you need 2 of each combination. I need 2 length plus width. I need 2 width plus height, width times height. And I need 2 length times height. What this is equivalent to is this could be like the front back. This could be the left right. And this could be the top bottom. So as long as you have 2 of each of every combination, you have all 6 faces, and then you don't have to worry about who's the base, who's the this, who's the that, if you don't want to. All right, the surface area formula is only true for right prisms. So for oblique prisms, we're actually, if we had one, we would have to find the area of each face individually and add them together. So for this year, for a geometry, we're only going to focus on right prisms. If you had to do an oblique prism, you could. It would just take you longer. You couldn't use the formula. But you have all the skills to do it. All right, find the lateral area and the surface area of the right rectangular prism. So you can use your formula, the pH, and then pH plus 2b if you'd like. For rectangular prisms, I prefer to use this or just plain old common sense. So what I would like to do for our lateral, we're going to know that we want front back and we want left right. So that's what we're going to do. So the front is 9 by 14, so is the back. So I'm going to have two 9 by 14s for the front and the back. Then for the left and the right, I'm going to have two 7 by 14s, and that's going to get me front back. I'm sorry, that's going to get me left right. So let's type this in here. 2 times 9 times 14 plus 2 times 7 times 14. That gives me a lateral area of 448 feet squared. Remember, area is always squared, so surface area included. Then for the total surface area, I'm going to keep the lateral and I'm going to want to do a top bottom. So I'm going to keep the 448 and I'm going to want 2 times 9 times 7 because those are the dimensions of the top and the bottom. So I'm going to keep the 448, 2 times 9 times 7, and that is going to give me 574 feet squared for my total there. Okay, you could have done it the pH and then the pH plus 2b way if you wanted to. You should have gotten the same answer if you would have done it that way. Alright, the lateral area and the surface area of a right regular triangular prism with a height of 20 and base edge lengths of 10. So careful here, this is a regular triangular prism, which means an equilateral triangular prism. So this is still coming back to us that we have to find the area of an equilateral triangular prism. Alright, so let's start with lateral. We know that's going to be pH. So if this is a regular with a height of 20 and base edge lengths of 10, then this is 10 and this is 10. So the perimeter is going to be 30. The height is going to be 20. So the lateral is going to be 600 centimeters squared. Okay. The total surface area is L plus 2B. So we already know our lateral is 600. 2. And then the area of a base. Now the base is a triangle. So we're going to put in 1/2 BH here so we can find the area of these triangles. So 1/2, base is 10. And remember the shortcut for finding an area for height of an equilateral triangle, when you cut it in half, this becomes a 30, 60, 90. So this becomes 5, 5 on the square root of 3, 10. Remember that half on the square root of 3 we talked about 150 times. Here it comes back again. Half of the base, which is 10, on the square root of 3, so 5 on the square root of 3. The 2 and the 1/2 cancel each other out, so we have 600 plus 50 on the square root of 3 centimeters squared. Okay, very good. All right, try C by yourself. Remember that you have a shortcut for cube if you would like to use it. Okay, our total surface area for a cube is 6s squared, the shortcut, because we have 6 faces. So for a lateral, we would want to use 4s squared because lateral would use the 4 around the outside. Once you get that, it becomes super simple. 6 times 8 squared is 384. 4 times 8 squared is 256. So we found both lateral and total surface area of that cube. Okay, very good. Alright, now let's move on to cylinders. Very similar. The lateral surface area of a cylinder is that curved surface that we know we learned when we did nets, that when we unroll that, that's going to become a rectangle. So that's that curved surface. The axis of a cylinder is a segment whose endpoints are the centers of the bases. So the axis is this imaginary line that connects the two bases together. It's going to go straight down the middle. In a right cylinder, the axis is perpendicular to the bases because that cylinder is going to sit straight up and down. The axis of symmetry in an oblique cylinder is not perpendicular because the cylinder is going to tilt to the side, so it's not going to be. So here you can see perpendicular for a right, not perpendicular for an oblique. And so when we have a right cylinder, the altitude and the axis of symmetry are this, or the axis of the cylinder are the same thing. Excuse me. All right, here we go. So here is your formula. So lateral is 2 pi RH, and the reason that is the formula is because we talked about the width of the length of the cylinder is the circumference of the circle, because it has to roll around that base, that circle. So that's where the 2 pi r comes from. And then the height of the cylinder is the width of the rectangle. So to find the area, length times width, I'm going to do 2 pi r times h. So that's where that formula comes from. Then for total, we're going to keep that lateral, so keep that 2 pi RH, but we need to add on the two bases, which is easy in this case because the bases are always going to be circles. So that's why I have the 2 pi RH, because that's the only thing I can have is the area of a circle. Okay, so let's look at this one here. We want to find both. So let's start with lateral, 2 pi RH, 2 pi, the radius is 8 and the height is 10. So that is going to give us 160 pi inches squared. And then for total, we're going to keep the lateral and we're going to add 2 pi r squared. So we're going to keep the 160 pi plus 2 pi h squared. So 160 pi plus 128 pi. And then what's that going to be? 288 pi inches squared. Here we go. So there's one for lateral and one for total. Oh, don't pixies. Okay, try example B by yourself. All right, so same concept, except for instead of giving us the dimensions, they give us kind of a formula. So circumference is 24 pi, and the height is equal to half the radius. So we have to solve before we can get started. So circumference is 2 pi r, and I'm going to set that equal to 24 pi. Immediately cross off the pi's, so 2r is equal to 24. So the radius is 12. If the height is half the radius, then the height has to be 6. Once I know the radius and the height, then I can go back to plugging in my lateral surface area. So 2 pi RH would be 24 pi times 6, 144 pi centimeters squared. For your total, we're going to keep that 144 pi and we're going to add on two circles. So 2 pi 12 squared is 288. 144 and 288, that's where I get my 432 pi. Okay, just like we did changing of dimensions in chapter 7 and again in chapter 9, we're going to do it again in chapter 10 so you cannot possibly forget it. Okay, so the edge length of a cube is tripled. What happens to the surface area? Well, we already talked about last chapter, surface area is the same as area. So we're going to take that scale factor and we are going to square it. So our scale factor is 3, squared is 9. So we're going to say the surface area is multiplied by 9. Or the surface area is 9 times as large, which however you want to say that. So they gave us the figure and they gave us an example, but we don't need to do that. It's twice as much work, well 3 times as much work if you do that, because you have to find the original surface area, find the tripled surface area, and then divide it out to get to times 9. So if you know the shortcut, you can just say, oh, 3 squared is 9 and be done in 10 seconds. Try B yourself. Okay, this one, this surface area, the scale factor is 1/2. So 1/2 squared is 1/4. So the surface area is multiplied by 1/4, or the surface area is divided by 4. Either one of those says the same thing. Last one, a word problem here. A sporting good company sells tents in 2 styles shown below. The sides and floor, that's going to become important, of each tent are made of nylon. Which tent requires less nylon to manufacture? Okay, so let's start with the pup tent. We are going to want to do the total surface area of this pup tent. So we want to do surface area is PH plus 2B. So perimeter, 8 all the way around, would be 24. The height is also 8 plus 2B. We know the base is 1/2 BH because the base is a triangle. So we just did one like this. The base is 8. The height is 4 on the square root of 3 because we know that trick now, that half on the square root of 3. Now this is a word problem, so we're going to want a decimal so we can type all of this in at the same time. So let's go. 24 times 8 plus the 2 and the 1/2 cancel. 8 times 4 square roots of 3. This is 247.43 feet squared for the pup tent. This is pup. Okay. Now let's go for the tunnel tent. So this one is a half of a cylinder. So we're going to want to do half of 2 pi RH plus 2 pi R squared. So basically we're going to want to, oh, I wrote the same thing twice, didn't I? So basically I'm going to get rid of these half and this 2, and I'm going to want to do pi RH plus pi R squared. Okay, so pi, 4, the height is 8, plus pi times 4 squared. Again, this is a word problem, so I'm going to want to use pi. So pi times 4 times 8 plus pi times 4 squared. This is 150.8. Now, what you have to remember is when I do the area of this half of a cylinder here, I am actually only doing the area of the outside, what used to be a cylinder. But now when I cut it in half, this tent, I would kind of like it to have a floor. I'm not much of an outdoorsy girl, but I do require a floor on the tent. So we need to go back and add that in because that's going to be made of nylon too, so we need to account for that in our calculations. So luckily we can see that this floor is just a square. So we're going to add on the 8 by 8. So 150.8 plus 64, 214 plus 0.8, and this is for the tunnel. So still, even with the floor included, the tunnel has less nylon to make. Okay, see ya on Monday.